Welcome back to The Explainer. Today, we're cracking open our trusty, worn-in engineering notebook to uncover a fundamental truth in software development: why technical success and product success demand entirely different types of evidence. We're going to dive right in because, honestly, fully grasping this concept is something that saves teams millions of dollars and just countless hours of wasted effort.
So picture this. Imagine you're on a dedicated engineering team. After weeks of absolute grinding, you've flawlessly built an AI resume assistant. You've created this complete, elegantly designed technical workflow. A user uploads a resume, the backend neatly catches it, an advanced Claude AI model crunches the text. The result is safely tucked away in a database, and a gorgeous front end displays the feedback. When you hit that milestone, there's a massive celebration, right? High fives all around. You can confidently declare everything works. It's a huge technical victory. It gives the whole team this deep, concrete confidence that the underlying architecture and the integrations are solid. The data flows exactly as it should. But let me just pull the rug out for a second. We have to ask the really uncomfortable question sitting quietly in the corner of the room. Do real users actually value this thing? Sure, the code compiles and the APIs connect, which, let's be real, is a minor miracle on its own. But do job seekers actually trust AI-generated advice enough to come back? Or better yet, are they willing to pay for it? A perfectly humming technical system literally cannot answer those questions. This brings us to our core framework for today's explainer. I want you to think of validation as two completely separate streams running parallel to each other. On one side, we have technical evidence. Does the architecture actually work? And on the other side, we have product evidence. Do users actually want this? These are two entirely distinct streams of validation, and figuring out how to navigate both is absolutely crucial. So let's dive into part 1, tracer bullets and technical evidence. How do engineers actually tackle that terrifying integration risk before they commit to building a massive mountain of features? Well, they use a tracer bullet. Now, this isn't about feature completeness, not at all. It is about blazing a thin but representative end-to-end trail through a real system. See, a front end, a back end, an AI model, and a database might all work flawlessly in isolation. But integration creates an entirely new world of uncertainty. A tracer bullet is designed to prove that these independent parts actually behave correctly when they are finally introduced to one another in the wild. Picture the exact journey a piece of data has to take in our AI resume assistant. From step 1, the resume upload, right through the back end, the AI model, the database, and finally back to the front end display. The engineers aren't building out every single feature. They are just building enough of the actual architecture to make that one single workflow actually function. And by pushing a real request down this single path, the engineering team stops guessing. They gather invaluable, concrete technical feedback straight from reality. They get definitive answers. Does the data actually move correctly between these components? Does the AI model integrate exactly the way we expected? Can the results actually be saved and retrieved? Basically, are our foundational architectural assumptions actually grounded in reality? But, and you really need to hear this absolute rule, a flawlessly executed tracer bullet strictly does not prove that customers actually want the product. It proves the pipes connect, sure, but it doesn't prove that anyone wants to drink the water. Technical success and product success are entirely different claims. Which naturally leads us to part 2, MVPs and product evidence. Now we're pivoting out of the code base and into the messy real world outside the engineering team. And we need to clear up a massive misconception right off the bat. Minimum does not mean poor quality, and it certainly doesn't mean a broken, glitchy prototype. It means building just enough capability into the product to create a viable offering that accurately tests the assumptions that truly matter. The purpose isn't to build a miniature version of every future feature, it's to generate hard learnings from real target users. Back to our AI resume assistant. An MVP here is all about seeing what real people actually do. If a user uploads a resume and gets feedback, we are testing our hypothesis about value and willingness to pay. We're gathering real product evidence, like do they complete the workflow? Do they ever return? Do they pull up their credit cards? An architecture diagram, no matter how beautifully drawn, simply cannot provide this kind of evidence. So look at how perfectly these two concepts sit side by side in our framework. A tracer bullet generates engineering evidence from an integrated technical path. An MVP generates product evidence from real user interaction with a viable offering. While both of these methods are absolute game changers for reducing risk and preventing massive investments based on pure guesses, you literally cannot substitute one for the other. Okay, part 3. Let's talk about what happens when things go wrong. The 2 failure modes.
What happens if a team confuses these two streams? Well, failure mode number one is honestly heartbreaking. It's when you achieve complete and utter technical success but suffer total product failure. The team builds the most elegant architecture imaginable. It's infinitely scalable, highly reliable, perfect AI integration. It is an absolute engineering masterpiece. And yet, the product completely tanks in the market because nobody actually cared about what was built. You solved the technical uncertainty, but completely ignored the human uncertainty. Failure mode 2 goes in the exact opposite direction, and it's equally brutal. Here, a team discovers massive customer demand. The MVP shows incredible user interest. People are practically kicking in the doors down for this capability. But because the technical direction was never properly validated, because no tracer bullet was ever fired, the chosen architecture is too unreliable, too expensive, or just far too slow to deliver that value. The whole system just collapses under the weight of its own success. Which brings us to our final section, choosing the right validation. Knowing these traps, how do we avoid false mandatory sequencing? Is there some magic rule that says you always have to do a tracer bullet before an MVP or vice versa? Nope, that's a myth. It all comes down to applying sound engineering judgment. Experienced teams don't just pick a buzzword and start typing. They stop and ask three fundamental questions. What do we currently believe? What is the actual cost if we are wrong? And finally, what specific evidence do we need to meaningfully change our decision? Your answers dictate whether you need to build a tracer bullet or an MVP. And hey, let's be super precise with our terminology here to apply this judgment right. A prototype explores an idea or a user flow, but it doesn't have to be a viable operational product. That is exactly why a slick, beautiful, clickable prototype does not prove someone will actually adopt the service the way a true MVP does. It's answering a completely different, much lighter question. The same goes for a proof of concept, or a POC. A POC asks a highly isolated technical question, like, hey, can this one specific library do this one specific thing? But a successful POC in complete isolation doesn't prove that the full, messy, complex workflow integrates properly the way a tracer bullet does. Again, different tools for different types of uncertainty. The real secret we are uncovering today isn't just a simplistic mandate to build small. The true principle is about being absolutely ruthless in hunting down the exact evidence needed to test your most critical current assumption. You have to reduce important uncertainty with evidence that can actually test it. If you're sweating over whether customers care, you need product evidence. If you're terrified the database won't talk to the AI, you need technical evidence. There's a quote from the source material that just hits the nail on the head, and it sums up this entire explainer perfectly. They aren't competing answers to the same question. They are different experiments for different questions. I absolutely love that. MVPs and tracer bullets are partners. They are distinct experiments beautifully designed to conquer entirely different streams of risk. So, as we close the cover on our notebook today, I want to leave you with one crucial provocation. Look back at your own projects. Before you sit down to write that very next line of code, ask yourself, what is the biggest thing you still do not know? And what exact experiment are you going to run to find out?